The second part of this lesson is simply just a lot of terms and then also different nuances between these different terms that you're going to learn. So in the first part of the lesson we talked about the difference between a line and a line segment, and here we see a line. Okay, this is a line with numbers on it, and we call this a number line, which makes sense, and I'm pretty sure you've seen this before. And with a number line, if we were to look at just a segment of this, so just a portion of it, we call that a line segment. So let's say we're looking at the segment from point J to point M. And let's say we wanted to know the length from J to M, or from M to J. So we're trying to find the length of MJ. And remember, when we're dealing with a segment, we put the segment symbol above it. And when we're dealing or trying to find the length of a segment, we can write this shorthand by just simply taking away the segment symbol above the letters. So we can write this as MJ. So if we're trying to find the length of segment MJ, we write it as MJ with no symbol above it. So if we're trying to find the length of JL, so from point J to point L, then we write that as JL, but with no segment symbol above it. So let's look first at how to find the length of MJ. So to find the length of MJ, so from point M to point J, we're going to look at the numbers or the coordinates of those points. So we see here the coordinate of point M is 4, so I'm going to write that down. And then the coordinate of point J over here is -4. And to find the length of the segment, all we do is we subtract those two values. So 4 minus a -4 would give me 8. And that's it. If we looked at the length of JL, so J, the coordinate of J is -4, and then subtract the other point, so the coordinate of L, that's 2, -4 minus 2, that's going to give me a -6. Now, keep in mind we're dealing with length, and length is always going to be a positive value. There's no such thing as a negative length. So because of that, I just take the absolute value of whatever is given to me. So if it's a -6, I'm going to make it into a +6. So the length of JL is going to be 6. So to write that in math notation, that you take the absolute value, you use these little symbol right here, segment straight up and down like that. That means you take the absolute value, or you make it positive. So write the little symbol right there. It means you're taking whatever value you're given and then make it positive. And this is what we call ruler postulate. The ruler postulate is the name we give to what we just showed. Now a postulate is simply something that can be assumed without proof. Okay, it's something or a statement that are accepted without proof. Another name you might see is axioms. These are the same thing, axiom or postulates. So the ruler postulate says that you can find the length of a segment by taking the absolute value of the two coordinates when you subtract them, like we just did a few seconds ago. Another postulate we have is what's called the segment addition postulate. And it's simply what it sounds like. You have a segment, or two segments, that you're adding together to come up with some sort of property that we can just assume to be true. So how this works is simply, if we take two segments and we add them together, so we look at EF, so from E to F, that segment, the length is 2. So write that over here, it's 2. The length of FG, from F to G, is 5. And the segment addition postulate says that if this one is 2, and then this one is 5, if I add them together, I'm going to get the length of the entire segment from E to G. So the length of EG is simply adding EF plus FG. I'm running out of room there. And so that's going to be 2 plus 5, which gives me 7. And that's it. So nothing too difficult. It's just a matter of remembering what it means and then how to use it. And now to finish this lesson off, there's only 3 more terms that we need to know. So the next term is what we call congruent. You've probably heard this term before. Congruent simply means 2 or more shapes that are the same shape and the same size. Okay, so 2 or more objects that have the same shape and the same size. So we see here, first example, we have 2 segments. Okay, 2 line segments that are both 4 inches. Okay, they're both the same shape, they're both segments, and they're both the same size, they're both 4 inches. So these 2 lines would be congruent. You see below we have 2 squares that are the same size and also the same shape. They're both squares and they're the same size. So these squares would be congruent. And it could be any shape and it could be any size as long as they're both the same size and shape. Okay, the next term we have is the term midpoint. The midpoint, by definition, is the point that divides the segment into 2 congruent segments. So we see here in this picture, we have the segment HJ. Okay, point I right here in the middle divides HJ, this segment, into 2 congruent segments. So see here, HI and IJ. HI and IJ are both congruent segments that have been created that are both the same size, both 6 inches, and the same shape. They're both segments. Okay, so we say HI would have to be equal to IJ. The length has to be equal. Or using the word congruent, okay, we'd say HI, that segment, is congruent to IJ. Notice the notation for congruent right here. It's an equal sign and then with a little squiggly line above it. This means congruent. Okay, and we'll talk about the nuances later between congruent and equal, but for now I just want you to be exposed to that and be aware that you can write it with that symbol. And then lastly, we have the bisector. So midpoint and bisector are very, very similar, but there is a very small difference. The midpoint is the point in the middle. So just how it sounds. Midpoint is the point in the middle. So we see here, this point right here is the midpoint. It is the point in the middle that creates 2 congruent segments. So that is the midpoint. The bisector is any shape that cuts through and intersects at the midpoint. So for example, I can draw a line like this, or in this case a line segment, there's no arrows. I can draw a line segment and it intersects here at the midpoint. So therefore, this line would be called a bisector. So bisector cuts it in half. The midpoint is the point where it intersects at the middle. The bisector could be a segment, as you see here, or it could be a line, or it could be a ray, or it could be a plane. It could be anything that intersects there at the midpoint.